Tony Talk.
Hey Tigers! Welcome back to TonyTalk.ai, the show where AI isn't just smart, it's sexy. I'm your host, Tony, and today we're diving into something deep. And I do mean deep. Ever wonder how Siri understands you? Or how Tesla's cars manage not to crash into every mail truck on your block? Well, today we're decoding that mystery with the magic of deep learning. And joining me is the queen of backpropagation, the enchantress of encoders, the sexy tigress data scientist, Mary, from her fancy gym in LA.
Hi, Tony. I just finished my hour of spinning. You sure know how to rev up a neural net. I came ready to train, test, and maybe overfit. Just a little.
So Mary, for the uninitiated, what is deep learning? Pretend I'm a young Tanthera tigress with a curiosity for convolutional kernels.
All right, Cubby. Deep learning is a type of machine learning inspired by how the human brain works. It's all about neural networks, which are algorithms structured like the neurons in our brains. Think layers, like an onion, or a very sexy lasagna. The input layer takes the raw data. The hidden layers extract features at increasing levels of abstraction. The output layer gives us our prediction. With enough data and training, these networks can recognize faces, translate languages, drive cars, even match your mood to a Spotify playlist.
So deep learning is like teaching a machine how to flirt back?
Exactly, except it's better at ghosting.
Let's go back. Like that back. Where did all this deep learning voodoo begin?
Ooh, history time. So the perceptron was introduced in the 1950s, basically a single-layer neural net. Cute, but limited. Then in the 80s, backpropagation came along and said, hey, let's train multiple layers. Fast forward to the 2010s, big data, GPUs, and open-source software like TensorFlow and PyTorch made it explode. Now we've got networks with hundreds of layers, like a digital skyscraper.
So we went from perceptron to skyscraper in one lifetime. I still can't get my microwave clock to stop blinking. So break it down, Tigress. How does a neural network actually learn?
Step 1, you give it inputs, let's say images of cats and dogs. Step 2, each neuron applies a weight to the input, adds a bias, and passes it through an activation function, usually something spicy like ReLU or sigmoid. Step 3, you get an output, say 0.98 for cat. But here's the secret sauce, backpropagation. If the output's wrong, the model calculates the loss, then adjusts its weights using gradient descent to do better next time. Rinse, repeat, for thousands of epochs.
So it learns by failing repeatedly, like my love life in high school.
If your love life used gradient descent, you might actually converge on something.
Let's talk architecture, Tigress. What are the greatest hits in deep learning?
We've got legends. LeNet, 1998. For recognizing handwritten digits, it's like deep learning's baby picture. AlexNet, 2012. The glow-up, first major model to win ImageNet with style, using ReLU, dropout, and GPUs. VGG, symmetrical and deep, a model with curves in all the right places. GoogleNet, Inception. Introduced Inception modules, kind of like building networks with Legos. ResNet. Solved the my network's too deep and now it sucks problem with skip connections.
That ResNet sounds like a relationship that skips arguments and goes straight to cuddling. Okay, let's talk about how we actually train these beasts. I keep hearing about loss functions and optimizers like they're gym supplements.
Pretty much. Training is all about minimizing the loss function. It's a measure of how wrong the model is. Popular loss functions are mean squared error for regression, cross entropy for classification. To minimize loss, we use gradient descent. Think of it like rolling down a hill to find the lowest point, but in 100,000 dimensions. Optimizers help us descend smarter. Common ones are SGD, stochastic gradient descent, the OG. ADAM, adaptive moment estimation, the overachiever, default for many models. RMS prop, good at handling noisy gradients.
So Adam's the optimizer you take home to meet your data?
Only if you want convergence and emotional stability.
I heard overfitting is a big issue. Sounds clingy.
Oh, it is. We need to be careful of overfitting. This happens when a model memorizes training data and performs terribly on new data, like a student who crams for their high school class, TikTok dance history and performance class, and fails. We fight it with dropout, randomly turns off neurons during training, keeps the model robust. Early stopping, stops training before it overfits. Regularization, adds penalties to the loss function to discourage complexity.
So, we train our models like we train our hearts. Leave a little mystery and know when to stop. Where do we actually see deep learning in the wild?
Oh, it's everywhere. Voice assistants, Siri, Alexa, recommendation engines, Netflix, Amazon, facial recognition, creepy but cool, self-driving cars, Tesla, Waymo, healthcare diagnostics, ChatGPT, obviously.
Wait, you're saying deep learning is responsible for that time Spotify recommended a breakup playlist before the girl dumped me?
Probably. It knows you better than you know yourself.
If someone wants to get started in deep learning, where should they begin?
Learn Python. Get familiar with NumPy, Pandas, Matplotlib, then dive into TensorFlow or PyTorch. Check out courses on YouTube. And of course, listen to TonyTalk.ai.
And remember, tigers, deep learning isn't just for PhDs or hoodie-wearing code ninjas. It's for anyone curious enough to ask, what if a machine could think? Mary, you've made backpropagation feel oddly erotic.
That's my specialty.
Tigers, stay curious, stay fierce, stay smart, and treat people how they want to be treated. Smash that like button and subscribe to TonyTalk.ai. Catch you in the next layer.
Tony Talk.